All right, y'all. We're looking at the excuse me. We're looking at the fourth day of our topic 12 notes, and this is talking about a couple of theorems. Okay, we're going to follow that same setup as we did in the previous one. We're going to first introduce a couple of theorems and then look at an example of what this could look like when you actually get some practice problems. Okay, so first, theorem number one, a diameter in a circle is perpendicular to a chord. That's the word you fill in right there. Perpendicular to a chord if and only if the diameter bisects that chord and its arc. Okay? That is a whole lot of words that mean a whole lot of different things. Okay, so let's break it down one little bit at a time. Okay, first off, the diameter of a circle. We already know what that one is, okay? That is a line segment that cuts across the middle of a circle, okay? It is a chord that crosses through the center of the circle and it cuts the circle in half, okay? Let's talk about that next word, the one that we filled in, perpendicular, okay? Perpendicular, the key thing that means is right angles. Right angles. Okay? Two lines are perpendicular. If two lines are perpendicular, that means they cross at a right angle. So that means, okay, so that's the first part of the theorem. It says that if a diameter is perpendicular to a chord, okay, so that means in this diagram we have a right angle made by the diameter and the chord where they meet each other. What that means for us is that this diameter bisects the chord. Okay? So that word bisect is something that we've talked about a whole lot in this class over the months. And that word bisect means cut in half. And it doesn't mean just cut into two pieces. It means cut exactly in half into two equal size pieces. So that means if you have a right angle right here, if you have a right angle between your diameter and your chord, that means this chord is getting split into equal size chunks. And the arc over here is also getting split into equal size chunks. Okay, that's what's going on with this theorem. It says if your chord is getting split in half, then it's perpendicular, and if it's perpendicular, then the chord and arc are getting split in half. Okay, that's layman's terms, and you'll see what some of the practice problems look like when you get to them. Our next theorem says that if a point is an equal distance, first thing to fill in, an equal distance from the endpoints of a line segment, then that point lies on the perpendicular bisector. That's the other one to fill in. Perpendicular bisector of the segment. Okay, so let's talk about what that means. Let's relate it to this diagram over here that is on your paper. Okay, what I'm saying, what this theorem is saying, is that if you have a point that's equal distance from the endpoints of a line segment, okay, so as you look at this right here, ignore the circle for a moment. Just look at the line segment AB on this diagram that's on your paper. This line segment AB, and there's a bunch of points over here, and you can see that the distance between A and H and the distance between B and H are the same. The distance from A to F and B to F are the same. Okay? If that is the case, then that means those points, H and G and F and E, are sitting on the perpendicular bisector of that segment. Okay? So that means H and G and F and E, the line that goes through all of those points, cuts AB in half, it bisects it. That's what that word bisect means. And it's also perpendicular, so it makes a right angle. Okay? The way we looked at this before, and that's the reason this triangle is over here, is we have actually seen this exact theorem before back when we talked about congruent triangles. We said that if T, this point up here, is the same distance from R and the same distance from S, and we know that's true because there's one tick mark on both of those line segments, both of those distances, then that means if you drew a line straight from T to the line segment, it would be perpendicular and it would bisect it. Okay? So that's what's going on. And when we see things like this in a diagram, when we see a perpendicular bisector in the diagram, that's saying that these distances from A to H and from B to H are the same. Okay, that's what it's getting at here. Now, with these theorems in mind, take a look at this here. Take a look at this here diagram. This is another diagram. Okay, I think this is probably the third or fourth lesson in a row that we get a diagram and it looks really complicated at first glance, but you're going to see how simple it really is when we get to the problem solving part of this. Okay? So first off, I see a bunch of numbers. I see a whole bunch of information. I see a 4 over here. I see a 6 right there. Okay? I see that the 6 is talking about this whole entire chord. That's what I see in that diagram. Okay? 6 is talking about the length of that chord CD. Now we also see right in here, let me highlight it for you. We also see right in there a right angle. And according to these theorems that we've been talking about, if you've got a right angle, something that is perpendicular from the center of the circle that's running into the chord, it is going to split that chord into 2 equal pieces. And we know that each of those equal pieces is going to be 3 units long. Okay? So what that does for us is it creates a nice, nifty little triangle that I'm going to outline right there. And in fact, we've got that triangle drawn all by itself right over here. Y'all, when you're looking for x, all we're really looking for is the hypotenuse of this triangle. So if we're dealing with the side lengths of a right triangle, all we have to use is our old friend, the Pythagorean theorem. A squared plus b squared equals c squared. And as we look at this problem, a and b, well, that has to be 3 and 4 because it's the 2 legs of the triangle. And c has to be x because that's the hypotenuse. Okay? Make sure that when you're plugging in something for c squared, that must be the hypotenuse. Always has to be the hypotenuse. Okay? A and b don't really matter, but c has to be the hypotenuse. So when we solve all of this, it turns into 3 squared, 4 squared is 9 plus 16. So if we're trying to get x by itself, we just take the square root, and it's the square root of 25, which of course is just 5. Okay, so if we're looking for x, all we're really looking for is the hypotenuse of that triangle. Okay, in fact, on all of your Canvas problems today, you're going to be dealing with some form of Pythagorean theorem. So make sure you are keeping track of what is a and b, what is the hypotenuse. Make sure you're keeping track of what the question is asking for, because sometimes the question is going to be asking for like the length of the whole chord instead of just one piece of it, or instead of just part of a triangle. Okay, so use those theorems, use your knowledge of triangles, and that's what we're going to use for this section of that's all we've got for this section of notes. That's all we're going to have for that section of Canvas problems. All right, so y'all have a good day.